All right. I gotta get my giggles out a little bit. This feels really weird. I'm standing in my living room. There's green fabric behind me. I've got this funny little microphone, and I am attempting to bring you science videos from my home. So here we go. I gotta put my serious teaching face on and be ready to teach you guys science. First, we're going to review water. You got to start reading the chapter with me. We did part of water, and then you got to finish reading it at home over the past couple weeks. So let's review the amazing, awesome qualities of water, because water is truly awesome. 3/4 of the world is covered in water. That's a lot of water. People are made up of 65% water. Your bodies need water. Water is found in every kind of food that you eat. I think our science book said that watermelon has the highest content of water, but all the way down to pumpkin seeds. Roasted pumpkin seeds are still 3% water. So we get our water not just from what we drink, but what we eat. Water is a kind of matter. Matter, remember, is anything that has weight and takes up space. Matter is made up of molecules. They are the tiny, tiny little particles that make up all matter. Atoms are the tiny particles that make up molecules. So atoms are the smallest, then molecules, then matter. Matter is what everything is made of. Did you know that atoms are so tiny that 500 billion trillion atoms could fit in 1 teaspoonful of water? That's a tiny little thing. A water atom is made up of 2 hydrogen and 1 oxygen. Those bind together and make a water molecule, and the more that bind together, the more water you have. Water is also amazing because it can exist in all 3 states of matter: solid, liquid, and gas. It is the only substance found naturally to do that. We can melt down something like gold in very high temperatures or freeze other substances, but water exists in nature in all 3 of those forms, as steam, as a gas, as ice, and of course in our rivers, lakes, oceans as liquids. Water's melting and boiling points are unique. Water melts at 32 degrees Fahrenheit, but it also freezes at 32 degrees Fahrenheit. Its melting and freezing point are the same, which means at that 32 degrees temperature, some of the molecules are solids and some of them are still liquids. The boiling point is 212 degrees, and at that point, it starts evaporating and becoming smaller molecules in the air. I should back up a bit because I forgot to talk about molecules and solids and liquid and gas and how the molecules act differently. In a solid, the molecules are really tightly packed together. They can't move very much. They can't vibrate very much. And so they stay really close together. In a liquid, the molecules are a little farther apart and bounce off of each other a little bit more. And in a gas, they're moving really fast and bouncing all crazy and very far apart and moving really rapidly. So the molecules act differently in different states of matter. So let's see, we had water exists as a solid, liquid, and a gas. Its melting and freezing point are the same. And you'll remember that really unique quality of water. Most substances, when they freeze, contract and get smaller and sink. Water, when it becomes ice, will expand and float. And that allows, in winter, for the ice to go to the top of the pond or lake so that it doesn't crush all of the plants and fish underneath and they can survive the winter. The last cool thing about water is that it has energy. Water's energy can be described like other energy: potential energy, meaning it's stored up, it's ready to be used, and moving energy. Moving energy is what gives us the ability to use water for work. Things like dams and water wheels and steam all help to power different things in our world. So that's my quick review on water, and the next one is going to be moving into the part of our chapter that's all about air and the atmosphere. All right, now it's time to talk about air. Air is made up of colorless, tasteless, odorless gases. So we got to talk about water, which exists in all 3 states of matter naturally. Now we're going to talk about air, which exists as a gas. the air that is found around the Earth is called our atmosphere. Earth is unique because no other planet has an atmosphere that can support life the same way that our planet can. And that's a good thing because plants and people and animals need air to live. There are only a few living things that don't need air. You can go for weeks without food, maybe a few days without water, but only a few minutes without air. So let's talk about what makes up our air. Let's do it somewhere different, shall we? How about here? In our atmosphere, air is made up of 3 different kinds of gases. When we talked about water, we said that the water atoms, the 2 hydrogen and the 1 oxygen atoms that combine to make a water molecule, would actually bind together. Well, in air, the molecules or the atoms of the gases don't ever combine. They actually stay separate and continue to be their own substance. They just exist together. So our air is made up of 21% oxygen. Of course, oxygen, people and animals need oxygen to breathe, and then plants can use the oxygen so that they can access their stored food. 78% nitrogen. Nitrogen actually goes back into the soil, and some plants with special bacteria create nitrates, which becomes plant food. And then 1% carbon dioxide. Carbon dioxide is what people and animals breathe out and plants use for their photosynthesis. Actually, oxygen and carbon dioxide should sound familiar to you because we did talk about them with photosynthesis. Now think about how all these 3 gases and plants and animals and people are all working together to make our life on this earth possible. People breathe in the oxygen from the air that is actually given out by the plants. The nitrogen in the air goes into the soil to make plant food. The plants give out that oxygen, and when people and animals breathe, they give carbon dioxide back to the plants. So everything about our air and the way people and animals and plants exist together is this really great, perfect cycle. There are also dust, water vapor, particles, and ice pieces in the air, but scientists don't consider those parts of the air. They're just existing and floating around. Besides helping us breathe, the atmosphere also gives us protection. It acts like a temperature control. So the atmosphere keeps the sun's rays from heating us too much during the day, but then it traps some of that heat so that we don't get too cold at night. It traps some of the sun's energy so that we can make it to the next day. The atmosphere extends 1,000 miles above the Earth's surface. Now you got to think back to what we learned about gravity and what we know about gravity. Gravity, of course, pulls everything always towards the center of the Earth. That means that the gases, the atoms of gas in the air farther away from the Earth are actually less dense. They're farther apart. But the closer they get to the Earth, because of the pull of gravity, they are more dense and closer together, which, again, makes it easier for us to breathe. And that's why when you climb a mountain or go up higher and higher, you can feel the effects of the air being thinner, and maybe you have to catch your breath in a little different way. Air is also found in soil and water. If you've ever done any gardening, you might have understood that if the soil is too packed together, is too close, and there's not enough air in there, the plants can't grow. They can't get their roots through. So that's why earthworms really are a gardener's friend, because they go and they break up the soil and they create little bubbles and pockets of air to give the plants room to grow. It also exists in water, which is why you'll maybe tap a glass of water and see the bubbles rise up, or you can trap air in water. So air molecules, air exists all around us. Our last segment this week is about air pressure. Air has weight. There's that expression, as light as air or lighter than air, but air really does have weight. It's very hard to measure. You probably can't do it on your own. But if you could box up a 3 cubic foot amount of air, that's 1 foot by 1 foot by 1 foot of depth box of air, it would weigh about 1 ounce. That's pretty light. Because air has weight, it is also matter. It has weight and it takes up space. Because it has weight, air has pressure. I'm not going to go into all of the details about pressure. You need to read that on pages 116 to 117 in your books, but I am going to talk about 2 examples. The first example is think about if you've ever been standing at a campfire. How many of you have ever gone to a campfire? You're out, you're camping, it's beautiful, the air is still, it's a calm night, and so you stand on one side of the fire, ready to soak in the warmth, and all of a sudden the smoke comes towards you, and you're a little confused because there's no wind. So you move around to the other side of the fire, and then the smoke comes towards you again. Well, that's a good example of air pressure. What's happening is that your body is getting rid of the natural pressure of the air on the fire. And when you weren't standing there, all the pressure on the fire is equal. So the fire just goes up and the smoke continues to rise straight up. When you stand there, you take away a chunk of that air pressure. And so on the opposite side of the fire, the pressure is greater. And so it pushes the smoke toward you, even on a still night. So when you move around, all you've done is changed where the air pressure is, and the smoke moves towards you because the pressure on the opposite side of the fire is greater than the pressure where you have taken it away. Here's another fun example. I have found here a cup, my kid's cup to use, that has a built-in straw. And so a straw, the reason it works is that when you put the straw in the water, wherever the level of the water or liquid or pop or whatever is, that fills up the straw with that. But everything on top of the straw that's not liquid is air. If you could put a straw in an airtight container, that means that no air could get through, then the straw wouldn't actually work because there's no air pressure to push the liquid up. When you suck on the straw, refreshing. When you suck on the straw, you're actually getting rid of the air that's on top of the liquid, holding it down. And so the liquid has nowhere else to go except to fill that empty space and go up. Here's something more fun. Okay, I'm not sure you're allowed to try this one at home, but I've got 2 straws here. I've got my little straw. I've got this straw that's naturally built into the cup, and the water level is about here. So that means in this part of the straw, there is water. In this part of the straw, there is air, and that is holding the water in place. But what I can do is I can take this straw, I can blow across the top, and I'm going to move the air from the top of the straw out of the way, and then the air in the straw is like, hey, what's up? I feel like unbalanced. There's empty space up there. We have to fill it. So the air from the straw is going to go up and fill the empty space I create, which gives the water no choice but to come up and out of the straw. Let's see if this works. All right. Got to try a couple times. Hopefully you can see that nice spray of water. That's air pressure. So air has weight, air has pressure, and air has temperature. And now air doesn't hold temperature very well on its own. There's a great diagram in your book on page 118. Air is transparent, which means it allows light to pass through. So imagine the sun spreading light and heat on the earth, and it passes directly through the air. But what it does hit is the water and the ground. And those molecules heat up. And since air molecules, air atoms are always bouncing around and continually moving, they start to bounce against the ground and the water. And when they touch the heated water and earth, they become heated. And that's why the temperature closest to the ground is often warmer. But because they are air molecules, they're also rising up because they're moving so quickly. Air has weight, pressure, and temperature. Pressure plus temperature equals wind. So because of the tilted earth and the heated air, let's see, the sun is constantly heating the earth and the water. The air molecules bounce off of that, get heated, and so then as they get heated, they start to rise because they're moving so fast, they're always wanting to go up. But when they go up, they create low density by the earth again, and so the cool air rushes in to fill up that space, just like in the straw, the air is moving. So if the warm air is constantly rising, going up this way, and the cool air is rushing down to that space, you've got these two different patterns of warm and cool air moving around constantly, and that creates wind. Wind does a lot of good things. Not only can we enjoy it for kites or sailing or something like that, but it also helps control the temperature of our earth by moving around hot and cold so that we stay at a comfortable, livable temperature. It helps with controlling some flooding, and it also, can't read my last thing. Wind helps us. I forgot the last thing I was going to say. That's okay. It's in your books. We also know that wind can sometimes cause damage. Hurricanes and tornadoes can do really bad things. Wind, the last point I'll make, is like water. It has energy, potential energy, moving energy, a lot of moving energy. And so people have learned for a long time now to use that wind in things like windmills to do work for us. So wind is another great thing we have in our natural world to use for us. Next week, we're going to take water and air together, and with their powers combined, we're going to talk about how they create weather. You might have noticed also that since we've been apart, I've developed my own superpowers. Like in the first two videos, I was kind of lower to the ground, and now I figured out how to get taller, and I can also do things like this. Change where I am. Ready? What do you think of that? How about this one? Yeah? One more. Wait a second. That's not what I meant to do. Oh my goodness. Guys, I brought Toothless home and now I think I've shrunk. I'm stuck in her cage. What do I do? Help!